Good morning, everybody, and welcome to the next webinar in a series of 3 with our partner BOS AG. Today, my colleague or partner Sean Lepoidevin from BOS will inform us about the new topic, the third topic, monitoring and maintaining your system. And to start with, I will introduce a little bit on Zoom webinars about Victron Energy, and then after that, Sean will take over. As the other 2 webinars were taken, the audience is muted during the webinar. The chat is used, so I'm sorry, it's not used. You can use the questions and answers section where you can write down questions during the webinar. And we, in this case, mostly Sean, will be able to answer those questions after the webinar. The webinar is recorded, so also this video will be able to see it afterwards. A little bit of information on Victron Energy. We are a company in many different markets. We are in the marine market, stationary solar, where we are discussing the topics today, automotive, industrial, home storage, and telecom. We are a Dutch family-owned company, and which was founded in 1975. Still a very small and agile competent team with a hands-on management. Due to the fact that we have been working on battery systems, we have a lot of experience, of course, over the years, and developed our products in this direction. If you want to know more about our trainings or our webinars, you can find this information on the homepage, where you see the link in the description below. We also have trainings specific on our products, where you can just attend to and get a certificate afterwards. I would also like to inform you about our blog. You can subscribe to this blog, and you will be informed about our new products, hardware as well as software. And of course, you can see references, so you can see installations of other customers. Also, like explained already, of one example is the BOS AG. Okay, this is already the part which I wanted to introduce. And now I will give over the word to Sean, where he can explain about the topic of today.
Yes, thank you, Bob. Thanks for the introduction, and welcome everybody. Thank you for joining our third webinar series on off-grid technologies and stepping through from beginning to end when it comes to both designing and installing a standalone power system. Today we're looking at I guess you could call the final part, which is looking after your off-grid system, the monitoring side of it, the maintenance, and if you're a solar installer, how to go about service and support. Like the previous ones, we're looking to go for about 30 minutes today. There's a fair bit of text in my slides, and it's also taking a little bit of the way I'll present will be a lot of field studies and based on my experience of things you need to be aware of and understand when you're looking at doing off-grid. So let's get underway. So first of all, today's poll question. So the off-grid projects and sites that you work on, wherever you are in the world, do they have access to electricity? Electricity, of course not. Internet source. So less than 25% have access to internet, about 50 to half and half have access to internet, or more than 75% have access to internet. And I'll just open up that poll. Sorry. Go. Yeah, so that should come up in the screen now. Just put in your answer and the screen should disappear. I'll also just turn up on video just so if people have a poor internet connection or anything, it might just make the video go a little, or your stream go a little bit better. Cool. All right. For those that are new to the webinar series, a bit of a background on BOS. We're a German-based energy storage and manufacturing company. We operate globally, predominantly in Europe, Africa, South America, and the Asia Pacific. As you can probably tell from my accent, I'm based in Australia, and a lot of my experience is Australian-based as well. We design, manufacture, and integrator of turnkey renewable off-grid solutions. So we, as the pictures below describe, pictures tell 1,000 words, we put together predominantly Victron equipment in nice neat enclosures ready for self-installation. The system capacities anywhere from 1 to 100 kilowatts of PV and 1 to 200 kilowatt hours of battery storage. And use cases are endless, mostly homes, businesses, schools, medical centres, government buildings, all sorts of things. So today's webinar, like I mentioned, we're going to be looking, a lot of it is to be honest, about service and support. It includes areas of monitoring and monitoring solutions, but taking a look at really from an installer's perspective about what you need to consider when you're selling an off-grid system and how to plan for that in the future. So once the system is installed, typically your relationship with the off-grid system or the customer won't end there. Maintenance for those systems. So just some very basic things that can, prevent issues occurring in the first instance, and remote solutions as well. So effectively remote monitoring and data as well. So that's, I should probably put remote and data solutions in there. There's a few case studies. I have referred to the Kate Health Centre in Uganda, as we have done in the previous webinars, but also some other bits of information from other installations completed. So starting off with service and support, what can service involve? I would classify this as customer education and operational training. So ensuring that your customer knows how to use a piece of equipment that you've sold them or that you've installed them, and training them. That can save you a lot of time. If the customer knows how to use the piece of equipment properly and not break it, not do things that they shouldn't do, that's going to avoid a phone call or a potential problem down the track. Answering customer questions. So they have a question about their system. They're going to want to call up. They'll send you an email, text message. However you communicate with your customers, quite often post-installation, they're going to ask you something, whether it might be very simple or it could be something much more tricky. System troubleshooting. So that could be, there is a problem with the system, the power's gone off, the solar controller is not working, the batteries are gone flat, the generator is not starting. How are you going to respond when those sorts of troubleshooting issues arise? Maintenance, so encouraging your clients to do proactive maintenance, things that they can do themselves, or if there's other maintenance that maybe you need to do as a solar installer, or engage in a third party to do more comprehensive maintenance on the system. System updates. So quite often, manufacturers, including Victron, will request that systems get updated with firmware or change of settings and things like that for various reasons. So that can be included in service and support. Performance review. Sometimes that can come under, answering customer questions, because they'll say, look, my system, I don't think my system's performing as the way it should be, or the way you sold it to me. How are you going to determine that it is doing what it's designed to do, or it is actually underperforming? So that can be a large part of system service and support. System upgrades, that can sometimes follow performance reviews, because we might find after you've done the system installation, the customer is now using more power, they need more solar, they need more batteries. Generally speaking, they just need a big system or a change in some respects. And research and investigation. So that sort of ties into all of it, but digging down into what a problem may be, or what a solution may be. So there can often be a fair bit of research into the issue itself, or solutions and things like that. So service and support, I wouldn't underestimate how time consuming or serious this part of doing an off-grid system needs to be as well. I've sort of just covered this slide in my previous slide anyway, but why is there going to be system service and supports, system or power reliability issues? The key reason why people have gone with an off-grid power system is for reliable power access. So if they're getting blackouts, the system's shutting down, lights are flickering because the voltage is not right or frequency, that's one reason why a customer is going to contact you. System warnings or notifications. Again, the system might be running, but there's a red flashing light or there's a buzzing alarm. The customer will contact you for that. Or if you train them correctly, they might look up the user manual and understand what that buzzer means or that flashing light means and solve the problem themselves, which is the outcome that you would pretty much want. Service and support could arise because of incorrect operation. Again, user involved, manufacturer updates. It could happen because of incorrect installation. And, myself included, everyone has the best intentions of when they do an installation, but sometimes you might have made a mistake, something didn't go right for whatever reason, and part of the system had a mistake in it. That causes an issue. Also, incorrect design. Similar thing, everyone has the best intentions, but sometimes we do make mistakes, and then that can cause incorrect operation of equipment and flow-on effects as well. So just keep that in mind, and external events as well. So, weather could damage solar modules, water could get in, there could be vandalism, unforeseen events. There's multiple reasons why problems can occur in off-grid systems, and I won't list the many odd things that have caused me to be involved in service of an off-grid system. So starting off with the most basic of elements, user education. So that really begins at the sales part of the system or the design phase. When you're discussing with a customer, what size system they need, you're going through their load profile, you're understanding the expectations the user has, and you're also setting the expectation with the user too. So, the customer's not expecting to be able to power, something really big, but you're sizing a system that's half the expectations of what they have in mind. So that can save a lot of headaches and really difficult conversations if you get that part of the system design correct in that very first stage, before you've even installed anything, is setting those expectations with the customer. Quite often getting that in writing as well. At least in Australia, it's very important that for the whole heap of legal purposes, that you get all these sort of expectations down on paper. In other parts of the world, verbally maybe just as appropriate. But I've got that line there. So that really represents after you've installed the system, you're happy with it, it's ready to go, and you've tested it first, and you're ready to hand the system over to the customer. So immediately after installation, or preferably as soon as possible after installation, that could be on the day, or if the customer is not available, you go back and meet them in person to explain, the system operation and everything about it. So in my experience, what I would do with the key operators of the system is first explain every component of the system. So that involves the inverter charger. What does that piece of equipment do? It takes generator power, it takes power out of the batteries and delivers it to their loads. Talk through the solar charge controllers, switches, wiring, all parts of the system. So they, generally speaking, will have, at least for that moment, an understanding that you've explained to them the parts of the system. System operation, do some test startups and shutdowns. Switch on and off circuit breakers, so show them that it's working. Quite often, again, in my experience, customers are a little bit scared of the system. They may be a little bit cautious and hesitant to touch any parts of it, thinking that they may break it or something will go wrong. So just showing the customer with confidence that you can turn the system off, you can open up this circuit breaker or fuses and close it up again, and it will turn on again. That can just build a little bit of confidence, and in a fault situation, that can also help the customer too, that they know, oh, back when the installer showed me how to do this, maybe I'll give that a shot. And sometimes, you know, turning the system on and off again can solve problems, just like a computer sometimes. Explaining user displays. So, you know, if there's a control panel, LED lights. So a lot of equipment will have different flashing LED lights. The different flashes of different colors at different speeds and different intervals mean different things, which I'll go through in another slide. And basic troubleshooting demonstration. Again, I'll sort of talk through this a bit more in other slides, but that sort of ties into the system operation. So just go through certain things. If a circuit breaker tripped off, or, you know, your generator turned off, what would happen, things like that. So this is really the user education, face-to-face preferable, or if you've got digital, you know, over a video call, it's probably the next best thing. Instructions and documentation. So this comes a little bit down to your installation, and also, I guess, the equipment that you purchase too. So one of the key things when it comes to helping a customer, especially over the phone or over email, is clear labeling of what parts of the system do or is having an issue. So particularly circuit breakers, you know, key circuit breakers, whether that's you know, isolators for the battery bank, isolators for your PV arrays, your generator, you know, your output power and lights. That can really help when you're trying to determine an issue with the system, because the customer is telling you, oh, this circuit breaker keeps turning off. And if that circuit breaker is not labeled, it's really difficult to know what that circuit breaker is doing. So in some instances, troubleshooting other people's systems, you know, without any labeling, it's really difficult, especially remotely, if you're not in front of the system. A restart procedure. So yeah, if the system does shut off, you know, how do they turn it on in the correct procedure or steps? Not just turning on every switch and everything that they can see. In most instances, it needs to be in the correct order, or it helps the system if you turn things on and off in the correct order. So a clear posted restart procedure. And if the customer is still having problems, where do they find more information, or who do they contact? So if they're standing in front of the system, they're pulling their hair out, they don't know what to do, where do they go from there? Do they go on the internet? Do they contact their installer? You know, what are the next steps? Again, part of what I would consider to be something that you should supply your customers with is clear documentation, wiring diagram. That probably doesn't help the end customer too much, but it can certainly help yourself when it comes back to potentially solving an issue with that system. So if you've done a wiring diagram, or have a wiring diagram available of how that system was wired up, the customer may say they've got an issue and you're trying to trace back where that issue is happening. You can sometimes diagnose that, you know, you actually made a mistake in your installation, because you're looking at the diagram and can see why such event is happening. And it's just really good to help in that instance. An operational manual, I would say that's different to a manufacturer's equipment manuals. An operational manual is typically a summary of the major components and how they all integrate together and operate together as a single system from a customer's perspective. So, you know, when a customer is looking at, you know, how to operate a system, they don't want to have to read the inverter charger manual or the solar controller manual or the battery manual individually. They want to be able to see a holistic approach to the system and the key things that the user needs to know, not really deep knowledge of inverter settings or battery stuff. So that sort of overarching operational manual of the entire system, and preferably graphical. My experience is that most people, unless they're really stuck in this instance, don't read a lot of text. They like to look at images, and yeah, images can tell 1,000 words in many respects. So photos, diagrams, things like that can help. And of course, including manufacturer manuals with the system certainly is a good thing. I'd highly recommend that. They don't always have their place depending on who your end user is. They may never get looked at in some instances. And furthermore, extra information that can both help you as installers as well as end customers as well. So that can be online videos, you know, videos on how to use the equipment, how to troubleshoot, features that equipment has, both Victron, BOS, and lots of other just YouTube videos in general, including this one will go up shortly. Has lots of information on how to use your off-grid equipment. Smartphone apps. Again, there's monitoring apps, which I'll get to in a second, but more specifically, you know, apps that can help you identify issues. One I really like with Victron, a lot of Victron products have the LED lights. You can go into this Victron Toolkit app, find your piece of equipment, click on it, and then scroll through every single different LED light combination until you match the combination that you're seeing on your device. And then that will give you a definition of what your piece of equipment is doing. You know, if it's a warning, if it's in a certain charge mode, which is really valuable. And internet forums, they can be a good source of information. Just be cautious that you know, an internet forum is not always an official source of information, but it can certainly provide guides and, you know, see what other people are doing and how other people may have solved certain issues. So quick intro, or just example of some of the instructions and documentations available. The equipment supplied from BOS, we include just quick start manuals, nothing too in-depth that will cause you too much trouble, but just quick dot points on how you set up an off-grid system, or at least a BOS off-grid system. We also have installation videos, and that's the top right, this one here. And also Victron has a lot of YouTube videos in many respects, both on installation, new products, questions and answers. So I would, if you're not aware, I'd probably suggest have a look at the Victron YouTube channel. Lots of good stuff in there. I'll watch that just about every time a new video comes around. You can learn a lot. Example of a diagram. I don't expect you to look at this in any detail, but this is a diagram for the BOS HS system installed at the Kate Health Centre. You can see it probably looks a bit detailed there, but if we get a customer call up and say one of the circuit breakers is turned off, because it's clearly labelled, we know why that's turned off, what it's feeding back to, and, you know, start to trace back where a issue may have occurred. And a labelling example. In this instance, we're using ductwork with all the cable, but yeah, each circuit breaker is clearly labelled, as well as warning labels. I know, well, obviously in Australia, we must have very specific warning labels of AC power sources, DC power sources, where batteries are installed, things like this. In the top left-hand corner, so this here, in this instance, it was a very simple shutdown procedure and restart procedure that we could post to the front of the Victron units. So again, if the customer needed a shutdown for maintenance purposes, they were moving the system, or we instructed them to do a shutdown to clear some errors or something, you know, it's clearly posted there how to do that. So we've got wow, just about 5 minutes to go. So I think I've got a couple more slides to go, but we'll see how we go. System maintenance, physical checks for damage to equipment. You know, that can be rodents, nests, in Australia, wasps and ants, and I assume in many other sort of warmish countries, you know, ants and insects. It's inside inverters can be quite warm. They like to, you know, build their nests in those warm areas, and then sometimes that can then affect electrical equipment, and so on and so forth. If water's got into any part of the system, into the cabling, into piping, ductwork, other types of damage, someone drove a car into the batteries, or swung a hammer in the wrong spot and smashed something. There's all sorts of ways equipment can get damaged, and you don't always know about it as well. Someone might not want to tell you that they accidentally hit the system with a hammer, type thing. Cleaning, probably the most obvious and easiest thing that end user can do. Cleaning solar panels, of course, it must be safe. If you're climbing up onto a roof, make sure that you're doing it in a safe way. Most of the time, I'd say solar panels generally can clean themselves, but if it's near any trees or in a heavily dusty or dust area, that can build up on the solar panel and affect performance. Cleaning fan vents, ensuring good ventilation through all the fan entry points and exit points. Ensure that it's clean around the area as well. So we don't want any flammable liquids. We want good access to the equipment. We don't want to build up a big wall of shelves and stuff in front of the solar equipment. Keep it nice, good access, so you can stand in front of the equipment, flick all the switches, look at the lights without climbing over things. A few more system checks. So looking at the actual system itself, are there any warnings or lights, errors or warnings? Again, the lights, the alarms. For something for a little bit more of the hands-on user or installer, look at the voltages, the PV voltages, battery, AC out, AC in under heavy load. Things like that can help if you're an installer and understand what is a good PV voltage or a bad battery voltage. Always write these things down as well if you're doing voltages. If there's a generator on site, test that, make sure it starts, make sure it synchronizes with the system. Again, check the voltage and frequency. Change oil and filters. One thing that I've quite commonly noticed is that customers forget that a generator is an engine, and engines need their oil changed just like a car. Same with filters. So make sure that the generator's got fuel in it. It's changed with oil and maintained like you would with a car engine. And for some battery types, complete a full or equalization battery charge. That's specifically important with lead acid batteries. Lead acid batteries need to get to a solid 100% quite regularly to ensure that they're being well looked after. And by doing that, that also helps to calibrate the state of charge of the system too. So whenever the system gets up to 100%, it calibrates the state of charge reading of the system, which is important. Troubleshooting, I could go on forever about this. I think I probably outlined it quite well in the beginning, but troubleshooting can range from very minor, non-time critical issues to very major urgent issues. So troubleshooting can be easy or it can be extremely difficult and stressful. As much as you want to say that you've done everything, nothing will go wrong, vast majority of the time, no matter how well you do something, the customer will call you about something. And it could be very minor, which is great, but sometimes as much as you try, something will go wrong down the track, and it might not be your fault. It might be that the weather blew over some solar panels, or I don't know, weather did something, or something outside your control affected the system. So again, very, very basic steps. First, I would establish clear communication. So clear communication with the customer is very important and will make your life much easier. In an ideal world, if you can be on the phone to the customer when they're standing in front of the system or on a video call, that's perfect. The customer can tell you in real time what is going on. You can communicate with them, steps to take then and there. Emails obviously good. Emails can be a little bit more, takes a bit more time. You've got to write out, there can be delays. And then second step, understanding the issue. Is it no power, are lights flashing? Is it just low battery SOC? Just understand, that gives you an idea if it's critical or not. Do get some information. You know, what is on or off specifically? You know, when they say there's no power, is that because a circuit breaker's gone off, or the system's gone off, or there's a cut in a wire, has a fuse blown? You know, start getting down to that detailed level of information. Have they installed new appliances, or have they changed the system in some way, which they haven't told you about? You know, all these sorts of things, yeah, help to understand what has gone wrong. And again, once you know the issue, once you got that information, then you've got to put your brain to work and really work backwards from that issue, and understand what could have caused XYZ to have happened. Again, when you do the installation, take as many photos as possible. They can come in very handy years later. And system data, I've got some more slides on system data coming up. And yeah, do your best you can. You keep calm and keep the customer well informed as well. That'll keep them off your back. So I see already at the 30-minute time frame. I've probably got at least another 5-10 minutes of slides, to be completely honest. So I'll just keep going. Hopefully you guys have all got a little bit more time, and we'll keep going. So monitoring system data. So what I've done in this is sort of separated monitoring, which a lot of you may be thinking, you know, internet portal, an iPhone app, things like that. And also separated that to system data, which doesn't necessarily need to be online. You know, a system can be recording data at all times, and you pull the data out of the system as well. So I've sort of crossed them over, but also separated them here as well. So I hope you pick up, and I'll try my best to explain that. So data monitoring helps to visualize the system performance for the benefit of the client and the installer. Of course, you can receive alerts of system errors and warnings. It helps to educate customers and engage them. So what I think you would want to see is, you know, a customer engaging with their system. If they just let you install it and then they never look at it, they never look at the state of charge, they never look at how much power they're using, that's almost a recipe for disaster in most instances. You want the customer to be actively engaged in looking at their state of charge. You know, it doesn't necessarily have to be daily, but, you know, just keeping an eye on things. Often many issues can be solved remotely with access to system data. So many of the questions that you may get from clients, if you've got access to live data, is great. You can often answer those questions just by looking at the data. You know, yeah. And, you know, monitoring of key system values, daily watt-hour consumption, battery SOC, PV performance, list goes on. So I won't go through that in too much detail. Yeah. So yeah, why is system monitoring data so important? So again, this is probably more focused on the data side of what comes out of a system. Accuracy, assuming that the system is recording data how it should be, the accuracy of information stored in that is 100%. There's typically no questioning it, which is really good. It's an independent, in a sense, independent information without influence. So what I mean by that is sometimes if you get a customer trying to tell you something is wrong with the system or certain events happened, they may exaggerate that event, they may get the time wrong, they may elaborate incorrectly or whatever. So looking at the numbers and the data means that you get accurate information that can't be changed by the customer. You can pinpoint the time of issues. So that can be super important because you can see at 3 p.m. on a Sunday afternoon, the power went out. And then if you go to the customer, well, I can see the power went out exactly 3 p.m. What happened on site? And then they say, oh, at that time, someone turned on something new or such and such event happened at site. So that can explain why the system may have had issues at that period and point in time. Various other reasons why point of time is very important. It can explain system operation, you know, where the PV is going in, how much is going to the batteries, things like that. evaluate loads and PV design or generation versus the design. So again, if you get that discrepancy or the customer's claiming that the system's not performing as well as what you told them would, it works in both your interest, yours and the customer's interest, to have that clear data and say, look, well, you're using this twice as much energy as what we estimated at the beginning. The system's doing is what it should, but because you're using twice as much energy, that's why the system feels like it's not performing as it should. Again, that's a bit about system performance. And of course, it saves going to site. If you can get a lot of this data, it saves you having to go to sites and doing all this sort of stuff manually, you know, the travel, the safety, the time, everything that comes with going to site. Here's an example of the Victron monitoring system, BRM. So data in this here can be live uploaded from a GX device, Victron GX device, or you need a Victron GX device. But if you don't have internet connection, it stores data from the system, and then that data can be extracted and uploaded to give you this same information too. So yeah, very, very helpful when troubleshooting. So active remote monitoring. So this is what I'm classifying in this instance as, you know, a system that is connected to the internet 24/7. Of course, it requires internet access. It can provide proactive identification of errors and system trends. So in a few instances, I've kept an eye on customers' systems, and I can see that they're using more power than what we originally sized the system for. So I've sent them a message or given a phone call and just saying, you know, are you aware of, you know, what's happening with your system? I notice you're using more power. And they may just say, oh, look, we've got family staying with us for a week. That's why our power demand's gone up. Or, you know, sometimes they don't know that they're using more power, and then they go and research why they're using more power than they were a week ago. So that is very helpful. Updating firmware remotely, that can sometimes be good, and also adjusting settings remotely. Again, there's quite a few settings in these systems, and it's not always possible to get them perfect on the day of installation as well. So sometimes you might go home and you've learned something from another site. You go, oh, I should really change that in the site I installed a month ago. So if that's connected to the internet, you can remotely change settings, which is fantastic. And just as I mentioned, if there's no internet, internal system storage of monitoring data can be downloaded from the system. The customer can do that in many instances. You know, if there's a USB device installed in the GX system, they can take that USB, send you the data on it, and then you can look over it from there. Monitoring solutions. So every manufacturer out there has pretty much got a monitoring solution. I would say a large part of many of them are very similar. You know, they all give you voltage, state of charge, power consumption, many things. I've focused on obviously the Victron one, and also third-party monitoring solutions that can be connected to Victron equipment as well. The Victron VRM, in my opinion, having used many different off-grid brands and things like this, I would say is the easiest setup. There's nothing worse than playing around with, you know, IP configurations and a whole bunch of computer stuff when you're trying to get it connected to the internet. Can be, or connect just in general, can be very frustrating. So certainly say Victron's the very simplest there. It offers remote control, which is what this screen here is displaying. That's the control panel that the customer would actually see. And yeah, probably quite biased, but I would say the Victron VRM system is the best all-round solution in many aspects. The third-party AMP, AMMP solution integrates multiple equipment brands. So if you're a large installer, you know, that has large fleets, you might have SMA, you may have Victron, you may have Schneider, and you want to integrate that all into one portal. AMMP is good for that. I forgot to update a slide. This probably isn't the best example of AMMP. This is a slide of 3 different systems. It has a color-coded chart, you know, that everything's good. If things are going out of parameters, you know, the little squares will turn yellow or orange or red, depending if there's a problem or not. In this case, everything's good, which is always good to see. And that's the end. So I actually did go 10 minutes over. I hope you're all still joining me. And yeah, I'll just see if there's any questions. Doesn't look to be. Just turn my marker on. Cool. Yeah, we're all good with questions. Bob, I might hand it back to you.
Okay, thank you very much, Sean. First of all, I must admit again, thank you for the very interesting presentation, and also very impressive how you got so much information in just a little bit more than 30 minutes presentation time. Well, we've seen the third webinar today out of a series of 3, and I think BOS, in this case Sean, has really given a very good overview for off-grid systems for you, for all the attendees, which you can use. I think the first part was about load assessment and site consideration, which I think is very important to have a look at always in the beginning. Then the second webinar was about system sizing and selection of components. And afterwards, today, we have seen how to monitor and maintain the system. I think that is very important to have a sustainable system running in the field. So for that, I think we have a very complete and much information in these 3 webinars. I already discussed this with BOS. The video presentations of the webinars will be available on their YouTube channel. And of course, we have the webinar outtake from PowerPoint. We have that in Victron Professional for download. So if you're interested and take a look at the information afterwards, it will be available for you. Yes, as I can see, there are not that many questions that came in today, although I have one coming in now. Sean, maybe you want to have a look at that one?
Yep. Hi, Kennedy. Is it possible to use VRM with systems with 12-volt battery bank? Yes, the answer to that is yes. So just about all Victron components, whether it's the smaller MPPTs or smaller inverters, inverter chargers, all have the V direct port or V bus, which can then go to a servo device, and that servo device can, or to a GX device, which can then go to the internet. So answer to that is yes. Answers to the poll. Oh, sorry. Yep, I thought I had shared the results of the poll. One sec. That should be live now. So just a quick look at the poll results. Seems it's all pretty even. So we have, 40% have 25% less. Yeah, less than 25% have access to the internet. Another 40% or 39 have 75% or more sites access to the internet, and then 20% is about 50-50. So quite an even spread there. That's quite interesting to know.
Yeah, quite impressive to see so many sites do have access to the internet. Nice.
Cool. We may have a question. Yeah. Hi, Jan. He or she's suggesting can't find much information about AMMP. The best thing I'd suggest is just look up AMMP in a Google search. Their web address, I think, has .io. So, but yeah, we can probably try and share a link. Not sure how to do that at this very point in time, but yeah, I'll probably just suggest Google it. It should come up. Yep, got it. Fantastic.
All right. Well, we can still leave the questions and answer section open for a couple of minutes to see if there are any other questions coming in. And if not, of course, that's no problem. If you might have questions afterwards, you can always contact us directly. Of course, for the BOS solutions, I would suggest you can contact Sean. And if you have specific topics, then then of course you can also contact me. Yeah, well, no more questions coming in. So I guess everything has been clear. Then I'd like to thank Sean and also BOS, in this case, for their presentations. I must admit it's very important, I think, to inform you about all the topics towards the perfect solutions in an off-grid system. And I hope to see you again soon.